right, we're coming in. Go. Good morning. Good morning. And let's start there. Let's go ahead and play. And let's not let's not start with the end of the lecture. Let's start with the beginning of the lecture. Behind the scenes here at Westmont College. Here we go. Okay, I should be big and in front of the screen, and we're good. Let's go small. I've got our audio playing. Great. Good morning, everyone. That was a little bit of a rough start. It's okay. We're getting better. All right, just for everyone out there remotely, this is our Westmont College Mayterm session. We are live in Santa Barbara from Winter Hall, broadcasting out to YouTube, and we've got some folks listening in from around the world. We think we have South Africa successfully watching. We trust that flows out there. Other people watching as well. We've got both people here locally, people remotely in the class, and then people just broadly on YouTube have been checking in from time to time. This seminar is part of a 5-week class on Introduction to Java. Today's lecture is scheduled for about 2 hours. And for the people in class, we're communicating on Slack on our hashtag broadcast questions channel. Any comments about administrative issues before we get going? Logistics? Okay. Get a little smaller. So just take a moment to arrive. Make sure that notifications are off, and make sure my notifications are off even. Cell phones, whatever we have available to us. And just want to take a minute to appreciate kind of the things that are going on around us, be grateful for them. Yesterday evening, I took a walk with the Dodger the dog, and actually ran into Tim, and I want to say Andrew, is that the friend you were with? I did a little improv work with him in orientation, but I forget his name. So anyway, this is Dodger this morning. He's doing okay. He had a good walk, and this is the Westmont garden on the right side, on the right of the picture. The garden was looking beautiful last night and relatively quiet on campus, so it was a nice moment. The flowers are all in bloom. If you haven't had a chance to get down there, you just want a spot to sit, some nice seating down there to just reflect on the chickens or whatever's on your mind. So this morning, I'm just grateful for the place where we are and for the dog and the way that walking the dog made me run into some of you on campus, which was awesome. So start with just that, acknowledging those good things. Okay, so administratively in our class, you guys have a Hello World assignment due tonight. Just as a reminder, that's simply a single class that you're uploading to Canvas just to demonstrate that you've got Eclipse working and we've got Canvas running okay. There is a quiz for Chapter 1 due on Friday, so the expectation there is that you will have read through Chapter 1 and do that multiple choice quiz sometime between now and Friday. You can take that over and over again. You'll get different questions each time. It's a pretty big pool of questions, and we'll retain the highest score from that. This is mostly a way to help you go through the reading. It's designed to just work in tandem with the process of you reading the textbook and, of course, the lectures as well. Over the next 4 lectures, so today is Wednesday, so Wednesday, Thursday, and then Friday and Monday, we're going to be covering chapters 2 and 3 if you want to continue going through those chapters. And we'll have quizzes on 2 and 3 coming up as well in the work. We're going to follow a little bit different order than we did during the regular term because I want to see if we can get into some of the more things related to data structures faster. So we're going to focus more on just the object-oriented stuff and kind of gloss over some of the primitive data types that you'll see referenced in the book. But I imagine, given the background that you guys have in at least one class in programming, Python in this case, that'll be pretty straightforward. So I don't think that'll be a problem. Okay, so the first thing that we're going to do this morning is actually also kind of a little bit administrative. We're going to attempt to get Saros running. Saros is a real-time collaborative coding plugin for Eclipse. Hopefully you guys have downloaded it already. I think most of you have. I know, Lisa, we had a problem with that yesterday. We were able to iron it out after class. So our first goal today is to get that installed and running, and in particular, we're going to share a project together so that when I code up here, you guys can see it as well. For the remote participants, this is only relevant if you are participating in real time, because we're actually going to be sharing code live. It's also only relevant if you are on Westmont's campus, because the server that we use to exchange the information between our computers is located within our firewall. So you either have to be on campus or you have to be connected by VPN. So the remote participants will be able to do their own work, and will be able to see the work that's going on here. But also the remote participants can pause and type stuff in as well, and so that's not quite as big of a concern here. All right, so what we're going to do is we are going to attempt to share my Hello World program, and then we'll each add our name to the output as that collaborative effort. Lisa, you got a question? No. So if that's showing up in the canvas, we haven't covered chapter 2 yet, and so that's an administrative error. So I will address. So the question was, Technique 2 is showing up as due today. That's an error, and so I will correct that. It will not be due before Technique 1, for example. Yeah, that'd be it. Okay, thanks. That's a good question. Okay, so what I'm going to do is I'm going to actually leave audio running so people can remotely can see. I'm going to turn off my face though, and we're going to shift gears to Eclipse, and I'm going to go ahead and keep talking, and then we'll work with you guys to see if we can make this happen. So the first thing I'm going to do is I'm going to shift to Eclipse, and I've got Saros down here on the lower right. It's visible as a plugin. If you don't see that down there, then what you need to do is go up here under Window and go under Show View and go down to Other. And if you've got Saros plugged in, you should be able to see Saros and the Saros whiteboard there. If you open them, they'll pop up down here on the panel. I'm going to expand this so we have a little bit more space to work with it. We can see all the people that have been registered at different points showing up as grayed out icons, meaning they're not online. Or more specifically, I'm not online yet with Saros. I'm online with my computer. But to connect to the Saros server, I need to hit this little plug right here, and you guys also need to have that plug plugged in. What that means is you're connecting to the server that's located on campus where all the information is being exchanged. Now, I know, Lisa, you set up an account. Have you, the rest of you set up an, Boaz, you got an account? Joy, Tim, you guys have an account? Okay, I didn't give you instructions for that, so that's not shocking. So let's do that together. Let me first connect to the system, and I'm going to connect with my account here. All right, we'll hear those noises periodically, which are sort of annoying, but that's okay. You can see that Boaz and Lisa are also online on this account. So for those of you who don't have an account yet that would like to, you should go under Saros at the top and create account. So since I'm going to see a different view from that, let me walk through that maybe. Tim, I can do that with you maybe. So do you see something that looks like this? Create an XMPP account. All right, so XMPP stands for XML message passing protocol, I believe. It is the technological name for a protocol otherwise known as Jabber. Jabber used to be the technology that Google Chat used for instant messaging. They've moved on from that, but this is an instant messaging protocol that can be used for all kinds of things. And so we have a server that is implementing XMPP instant messaging. So Saros sends all the updates about what we're doing in their code as instant messages through this server. So the first thing that we want to do is for our XMPP server, you can use ones that exist out in the world if you want, that are publicly available. That's the default here. I don't actually know if that one's running. That one's provided by the people who made Saros. I set up our own here on campus at vmwardrobe.westmont.edu. So you'll need to enter that in as the XMPP server. And then you can choose your own username and password and repeat password. And then, well, you don't choose your repeat password. You repeat the password that you previously chose. And then you want to make sure that you check Use New Account immediately. And if that works okay, you're going to appear in my list right away, I think. Or maybe, no, you know what? We have to go through a friendship exchange protocol first. So let me check first to see if you guys successfully connect. Does it appear that your window closed cleanly? No, because we all have to be on the same server in order to see each other. So I can show you that again. So the question was, is it fine to connect through the Berlin server? And the answer is no, because you only see people that are on the same server. Furthermore, the reason why we set up our own server is so that it would be reliable. We could control it and bring it up and down, and also because we wanted the latency to be fast. We wanted the messages to happen very quickly so that edits don't get delayed. Okay, so what is your username, Tim? TM Stolson, like that. I'm just going to put you down as Tim. TMS. You should see something like an invitation from Patterson. Yeah. Great. All right, so you are now on my friend list. I can see that you're online, and I need to do the same with Joy. What do you got? Jay? Yeah. Got. All right, so you should see an invitation request. Great, and you are online. Maybe you just invited me. Okay, so 4 of us are online. That's good enough to get started. The next thing that I'm going to do now is I'm going to share my actually, let me make a new project for us. This one's sort of left over from before. My new project will be hello. Oops, sorry. I need to make the type of the project. It's going to be a Java project. Next, I'm going to use 1.8. I'm going to call it Hello World Live. Use 1.8. Next. It's all good. Finish. Now I got a live project. I'll make a new class called Hello World Live. Add a main method to it. Finish. I named it something weird with a typo. Let's try that again. Okay, and now I'm going to add a single line that shows hello world at the output. Actually, what I'm going to do is I'm going to model for you what I would like you to do, which is to type in your name into the string. You can't do that yet because I haven't shared the project. So what I'm going to do now is I'm going to share that project. So I'm going to come under here. When I share the project, what Saros is going to do is it's going to ask you whether you want to synchronize an existing project, meaning do you want to take the files that I have and overwrite your project with those files, or do you want to create a new project where you copy my files for the first time? You can do either, but it sort of makes sense to copy a new project at this point. So I'm going to share this project. I'm going to pick which project I want to share with you, and then I'm going to get an option to select whoever happens to be online. Finish it. And you should see that show up. So it doesn't really make a whole lot of sense in this context, but there is a little chat window over here. And then also, as just for fun, there's a whiteboard, so you can draw pictures and it shows up in other people's computers as well. So if you switch tab, you should see my beautiful squiggle. All right, so in the meantime, it looks like everyone has connected. So 1, 2, 3, 4, that's good. None of you are looking at the file that I have open, so why don't I have you open up the hello world live.java program, and why don't you duplicate the line that is saying this is Professor Patterson and use Saros to change the code so that it adds your name. There you go. There's someone like Joy, Boaz. So now you can sort of write over one another on this, and so that can be a little crazy making. So do your best to, there you go. Awesome. Professor Tim, glad to have you here on board. Make sure you put a semicolon at the end of your line so that it compiles cleanly. right. I'm going to put a semicolon at the end of your line, Boaz, so that it files okay. Try. There you go. You beat me to it. All right, so then you can save it, and if you run it, I'm going to right-click over here. I always feel better about that. We should then be able to see everyone's output in the code. There we go. Great. Now, if I decide to break this session in Saros, what you're going to see is you're going to see that the file remains, but all the sharing is going to go away as that happens. So great. All right. So that was remarkably successful. Any questions about that? Later on, what I'll do is I will have this file open, and I can restrict it to being read-only. Oh, so one other thing that's helpful to know is in your interface, there's these little glasses right here that are on top of one of the people icons, and you can select someone that's in the sharing group right now to follow them. And what that means is as they're editing, as they switch files, you're going to jump with them to whatever they're editing and however they're moving through the file system. So that's helpful later on if I start working with multiple files and you're losing track of where I am. You can just follow me and watch the edits that I make in real time through different files. So that's pretty helpful as well. Okay, any comments, questions, everything working okay? Great. All right. So let's okay, so what we did is we took our Hello World program, actually made a Hello World program really quickly. I put my name in it, and then we got Saros up and running. So we are all now communicating through that local server, and you guys added your name to the output. So great, well done. All right, so what chapter 2 is about it's about using objects. So it took a while in our Python class to get to the point where we were talking about objects. In Java, we don't have to, but we're going to talk about objects right from the beginning because everything in Java is driven by objects. It's really the first-class citizen of Java. It is the primary mechanism by which work is done in Java. So a class, or I'll use the term class and object somewhat interchangeably. An object is a specific version of a class. So I often use the metaphor of a class being like a recipe. Imagine like a cake recipe or a chocolate cake recipe or something like that. The object is the actual cake. So you have one thing that is a recipe for the object, that's the class, and then you have the actual cake, the actual class instantiated, which is the object. So one is an idea, and one is the actual object being used. Objects contain several things. They contain both data, and they contain methods or functions that work to manipulate that data. But they encapsulate them. They keep them all together, and you can move it around your program so that all the data that's related to each other stays together. So a real classic example is thinking about a profile in a website. You might have an account where you have a name and a birthday, a gender, an address. All that data is associated with you as an individual. And so we might imagine an object which is a person class, and it contains all that information, and we move it around. And we might have kinds of objects that are like send a message or change your name or those kinds of things within the body of that object. So when we do this, what we're doing is we're creating an abstraction. It's a big word to describe the idea of taking some data and trying to get it to represent something in the world or some idea that we have and keeping it all together. So we see some of these things already. So we encounter these ideas of abstractions all the time. We don't always think of it like that. But anyone know what this is? You guys aren't homeowners yet, I don't think. But yeah, it's a water heater. So this is some basement somewhere, and it is a water heater. So the way this thing works is it fills up with water, and then usually there's some kind, in the US, this is the way it works. There is a gas flame down at the bottom, usually natural gas. And that heats up the tank of water, and then as you take a hot shower or you use hot water in a sink, the hot water comes from this tank, cold water comes in to replace it, and this tank is it's insulated, and so it's constantly trying to keep enough hot water so that when you turn on the tap, you get hot water out of it. So this is a way of getting hot water. Well, another way of getting hot water is something called a tankless water heater. These are relatively new, although it's relatively new in the US. I know we had one in Japan probably 25 years ago when we lived there, so it's not new to the rest of the world. This is a different model of a hot water heater. What it does is it has water running through it, and when you want hot water, it turns on a flame usually. Immediately, the water runs over that flame and there's no tank. It just gets so hot so fast that it's on demand. You want water, cold water runs over the flame, hot water comes out the other side. There's no tank. So there's pros and cons to them. Obviously, the tankless water heater is not going to leak in the way that a big water heater might. The tankless water heater has infinite supply of hot water in the sense that the tank, when you run out of hot water in the tank, your shower goes cold. And if you have a big family, you're certainly familiar with that experience of someone taking a hot shower before you and you getting a cold shower. Thank you, Brian, my brother. And so the tankless hot water heater avoids that. It's a little bit higher, a little more technology, a little bit more maintenance usually, a little more expensive usually to use a tankless hot water heater. You might also have a hot water heater that looks something like this. These are some, they're not photovoltaic, they're just black pipes on the top of a roof in China. Just happens to be a picture in China. You can get them all over the world. This isn't unique to China. There's a little tank at the top, and what happens is the sun shines on those pipes that are coming down that look like rails of a fence, and the water circulates through them, and the sun heats them up, and so the heat from the water is generated just by the sun on those black panels. There's no electricity involved. It's a kind of a nice, clean system, provided that you live somewhere sunny. This picture is not particularly sunny, but it would work great for us. So the reason why I bring these up is these are all abstractions of hot water supplies. You can think of them as all being the same in one way. They all supply hot water. And if you plumb them correctly, they're more or less going to work the same way. When you turn on the hot water tap, you get hot water. And you don't really have to think very much about the data or the hot water that's stored in it. As long as it behaves the right way, you can kind of swap any one of these in or out. And we use objects a lot like this. We define what behavior we want from the objects. In this case, the behavior is we want hot water. And then we define the implementation. Well, how are we going to get that hot water? Tankless, natural gas, solar. And because the interface is consistent, two pipe in, a pipe out, maybe gas or electricity, we can swap those in as we want them. There's an analog to this in what we're doing in Java because we encounter them all the time. So there are all kinds of other instances where we have abstractions. So power plants are an example. We want power at our electrical outlet. We can get that from a solar power plant. We can get that from a coal plant. We can get that from a nuclear plant. We can get that from a diesel generator. We can get that from hydroelectric. We can get that from wind. All those different places are different abstractions of power plants that we can move into the system. Vehicles, the same way. If your idea of what you need from a vehicle is to get from point A to point B, then you can use a motorcycle. You can use a bike. You can use a bus. You can use a Ferrari, in principle. You can get your hands on one. But, of course, if your behavior that you care about isn't just getting from point A to point B, you can't swap things in, right? So if you want to move your apartment, then it's not going to be sufficient to have a motorcycle. You have to have something that has the behavior that you need, carrying lots of stuff, like a pickup. Can you think of any other examples of abstractions that you run into? Stoves? Yep, that's pretty good. In what way could you swap out different implementations of a stove? Huh? So that's kind of a different, that's not the way in which we're thinking about the abstraction, although the stove itself is a good example. But the way in which I would say the stove is a good example is rather than using multiple functions of the stove, you can implement the stove in different ways. So you can have a gas stove, or you can have an electric stove with the coiled burners, or the flat glass top, right? Or what? In principle, I guess you could have a photovoltaic stove, like a solar oven or something. So now all the things that you described, the timer, What else does stove sometimes have? Maybe they have like a brown, something that browns stuff. That would be examples of like methods in an object. And as long as every one of your stoves had those methods, they would be interchangeable. But the more methods you add, the harder it is to do different implementations. But you guys, can you think of anything? Writing utensils, great. So example, maybe a pencil and a pen. If your goal is to just write something down, those would be fine. Yeah, you could swap them out. So those, the class in that case would be writing utensil, and then the implementation would be pen or pencil. Okay. Any other ideas? Water bottle. I guess like if you're thinking like hydro flask versus Starbucks cup versus plastic bottle, as long as what you care about is holding water, I guess a sponge could swap in. You want to? Just kidding. Oh yeah, that'd be good. Just don't get them wet. How would that work? How can you eat it if it's filled with water? How do you? So it's some sort of rice paper gluten outside filled with water, and you. So is this like what you get at like Yogurtland? The like little. You know what I'm talking about? The things at Yogurtland. They're boba, but they're the boba that have that are like the juice inside, not the solid ones. I wonder what keeps them from just like the liquid inside just eating its way out. Someone smart. Maybe like if it's too sweet or something, it doesn't work. Okay, so like we said, notwithstanding the fact that the mystery of boba with liquid inside remains outstanding, Java programs are 100% objects. So it's just going to be one abstraction after another. We've said that an object contains data, it contains methods that change that data, and importantly, they're designed. So they are things that people create, different programmers create, and they're designed to accomplish particular tasks, to behave in particular ways. And as a programmer, this is a really important distinction to get your head around. You can either design and implement the object, so you can be the person that's responsible for building the water heater, or you can be a programmer that uses the object. So just like you need someone to build the water heater, you also need a house builder that just uses the water heater. So the role of a programmer can be both an implementer and it can be someone who maybe is a like an API programmer is maybe a good way of thinking about it. You can be using the object or you can be writing the object. And those are two roles that we're going to take on during this class. And if you remember that those are two different roles, that even within one program, you take on both of those roles as you make a class that you're going to use and then you use it. You switch back and forth between those roles very frequently in Java because everything's an object. So a lot of this programming is about knowing the objects, knowing how to compose them, and put them together in ways that accomplish what you want to have done quickly and efficiently. Okay, so let's look at an example that we've already seen. We've already, in our Hello World example, used an example of an object called system.out. System.out was an object, remains an object, and it had at least one method. We know that because we used it. It was println, printline. How does that work? We don't really know. And this is like saying, how does the hot water heater work? We don't really know. That's an implementation detail. When we use println, we're using it as an API programmer rather than as an implementer. So as long as it expresses the behavior that we want, which is to put something onto the console, we don't have to worry too much about how it works underneath the hood. I say that at a certain point, you do have to start worrying about how it accomplishes what you want it to do because you can choose inefficient ways of accomplishing things. But at a high level, you just don't particularly care about what it does to put text onto the console. You just want it to do that. And so we use println to do that. Every object expresses some behavior, and that behavior is a combination of how the data and the methods work together to accomplish some task. So print stream is an example of an object that has the behavior of putting things on the console. So I have this little diagram over here that shows this red box that encapsulates the idea of a print stream object. It's got a class name. Now, we never actually saw the term print stream show up in Hello World, unless you happen to see it in one of the suggestions or something. That's a type, and that is what system.out is, even though we haven't seen it. And so system.out has within it some data, some internal variables. We don't know what it is, but it has something inside it. And it has some methods, for example, println, and it also actually has another one called print, and it has more beyond that as well. So what I'd like you to do is I'd like you to go into the Hello World program, and I want you to try using println and print and try and observe the difference in the behavior between those two, recognizing that when you do println and print, you are calling methods in an object, two different methods in the same object. So what I'm going to do is I'm going to switch over to Eclipse, and I'm actually going to switch us out. So I am going to break my session so that you will have just your own copy. All right, so now we're broken. Our system is broken, so we are no longer sharing our content. And what I'd like you to do is just for the next 2 or 3 minutes, try to get a sense of what those two different commands do. And we'll go offline here for 1 moment as we do that. All right. So what we're trying to do is explore println and print and look at the difference in behavior between those two methods. And I will leave the screen up, but I will turn off audio. Okay, we are back online, and I think, there we go, let's make it smaller. All right, so what did we discover? There you go, great. So there's a difference in behavior between what happens at the end of the line that you print. If you do multiple prints, they're going to continue printing on the same line. What happens if you do a print and then a println? It continues on the same line, that's right. So mentally what you can think about is you can imagine that there is this kind of cursor that exists in the console, and whenever you call print or println, it's going to start printing at where that cursor was, and then if you called println, the cursor is going to go to the next line and wait for the next command to come in on the next line. But if you call print, the cursor is going to stay at the end of the previous text, and the next time you call print or println, it will continue from where that cursor is. Okay, so that's helpful if you want to do something where you continue printing on the same line, but also it helps expose the fact that this print stream object has two different methods that are a part of it. And they describe, they start to sketch out some behavior for what is happening here in this object. Okay, so let's step back for a second. What exactly is a class? I mentioned this briefly as I was talking about the recipe. The class is like a recipe for objects that are all going to have the same behavior. So one that we've used but haven't called out as being a class already is the string class. So on the slides here are 3 different strings. Strings are series of characters that are within quotes. So we've got hello world, Professor Patterson, and I'm going to botch this, but ni hao ma, maybe. How are you in sort of informal how are you in Chinese. Okay, I have no idea what I'm talking about. I know it's kind of hello in Chinese, but if someone's actually in China calling me out on how it's not exactly hello, I totally own that. Regardless of that, the point is that each of those are examples of objects which are of string class. And each of them have the same behavior, meaning they are collections of characters. And I threw in the Chinese one to emphasize the fact that they're actually Unicode or international characters, not just Latin characters. And each one of those strings have behavior associated with it in that you can call methods on those strings. So strangely, you can actually put a dot at the end of those double quotes and access methods that are part of the string class. Joe, you look like you desperately want to correct me. Because it's not a traditional phrase at all. So it looks like I'm, this is the traditional version, so it looks like I'm a museum text or something. Yeah, okay. All right. Fail. Tried. Trying to represent China, but okay. I'm giving a pass. Okay, so strings all have the same behavior, and that's because they're all made from the same recipe or the same class. But you can see that they don't contain the same data. They're not the same. It's like 3 different cakes. They're all made from the same recipe, but they're not the same cake. They contain different eggs and different flour, and they will get used differently. So the same way, system.out is a print stream class. There are actually other print stream objects that can write to other places other than the console. We don't use them very often, but they also have the method print and println. But when you call them, rather than having that output go to the console, they might go to a jumbotron. They might go to a file. They might go to the internet. They might go to an audio output. You don't really know, but they have the behavior that is consistent with a print stream in that they output characters somehow. Our particular one, system.out, prints to the console. So that's an example of how the same class can be repurposed to do different things. All right, so 2 classes, strings and print stream. They're both objects. They're both objects that are created from different classes, and each of those classes has their own behavior. And you can think about this as a hot water heater is one class that has one kind of behavior, but a power plant is a different class and has a different kind of behavior. They're both objects made from a particular class, but they have different roles and they do different things. And you can't swap out a hot water heater when you need a power plant. It just doesn't work. You can't swap out a print stream object when you need a string object. That's not going to work. They don't have the right behavior and they're not going to do what you want them to do. And in fact, in Java, not only will they not do what you want them to do, but the language itself will say you are not able to do that because you have created a slot in the shape of a string, or you've created a spot in the shape of a print stream object, and if you're trying to put one in the wrong slot, I'm not going to let you. And that helps us to make more correct code. Strings, print stream objects, hot water plants, power plants, they all have different behaviors by design, and I call that out just to point out that there's a person or a team of people that are making these objects. And so given the appropriate skill, you can also make these objects and create behaviors that are helpful for you, depending on how much time and effort you want to expend in creating these objects. Okay, so let's take another pause, and let me have you try this out. The question is, what happens if you try and print this code out? So it's hello world.println system.out. Let's take a second to try that out and see what we end up getting. How'd we do? What happens? Great. Can I share it with you, Boaz, and see if we can see what you're seeing? All right, so what I'm going to do is, actually, you can share with me. You want to try that? Look at that. Awesome. I've never done it in reverse. All right, so I've got Boaz's project up here. He's got Hello World here, and we're looking at it. So this looks like the correct version. Did you correct it? So that's printing out Hello World. Is that what you see on your screen? Oh, well, that's good, because that explains it. So, okay, let's break that session. I'm going to break it. I'm back online. Delete that project. Any luck? Great. Request. All right, so I've got an error. I'm looking here and I see this X. So I'm expecting that as I go down this hierarchy, it's going to show me where the errors are. I get here and I see that, oh yeah, in fact, we do have an error. All right, now I can get some insight into what's happening by hovering over this error here, and it'll tell me what's going on. And it says the method println print stream as an argument is undefined for the type string. So someone else tell me what is breaking here? Any idea? Uh-huh. Yeah, I think you see kind of the problem. The language that you're using isn't the Java language yet, but I think you're onto it. The way that I would describe it is I would say that there is a string, and we're trying to call the method println, and we're assuming that println is a method in the string class. We're using that dot notation. What that dot notation does is it says, go into the object and call the method println. Go in. String is an object, but it doesn't have a behavior that includes a method println. And so the error that we're getting here is Eclipse is saying, hey, a string class doesn't have a println method. What are you even doing, crazy person? And it's giving us an error and saying this isn't going to work, and so I'm not going to compile. So what we need is we need to call println on something that actually has a println method. So if we do something like, I'm going to copy that here. I'm going to comment this out. We'll talk about comments in a second. Well, we know that println is a method that's part of system.out. So if we do that, then we're going to get that error goes away, because now we've got println is a valid method that's part of the system.out object. I'm having trouble speaking. We're getting one other error because we need one more curly bracket. All right, make sense? You can only call the methods that exist in a particular object. All right, we'll dig into this a little bit more in a second. So let me see. I'm going to break out of here. OS. There, I can leave. Okay, so the problem that happened was println isn't a method that string class provides, and so Eclipse wouldn't allow that to happen. All right, take a moment to shift gears to a different topic, which is about talking about variables. And variables are a way that we can store data. So we know that there's data within these objects, and we need to develop some understanding of how to store those things. From Python, you're very familiar with using variables. In Python, when you want to make a variable, you just name it and use it. In Java, you have to have a little bit more communication with the compiler before you can use a variable. The goal of a variable is to store data, different kinds of data. And the way that we do that is with a line like this one here. And there are different components to what's happening. So let's talk about what we've got. The first thing that you see there, that capital I integer, that's the class or the type of the object that we are creating. And you know it's a class because it's starting with a capital letter. By convention, we start all classes with a capital letter, but we start all variable names with a lowercase letter, and that helps us to understand what we're working with within our code. It's just a convention. So we've got integer, which is the type, and then we've got width. Width is a name that we chose to hold data, so it's a container that's going to hold our data. It is of type integer, meaning what we can put into that class is only something that is of type integer. We're going to initialize it with the value of 20, and so we're going to use that equal sign. And then in Java, every statement has to end with a semicolon to say that it's complete. So in this one line, we're reserving space for an integer, and we're initializing it with the value of 20. Right? It's a variable. It's a very typical thing that we're going to do all the time. So we've got that. Some rules about variables. Maybe if we want to think about metaphors for them, like we were thinking about the hot water tank, a variable is like maybe a parking spot. And you can think about the parking spot as being a place that's going to hold a car, just like the variable is a place that stores data. And if you want to use that as your metaphor, it doesn't go too far, but you can think about the type of a parking spot being what kind of car is allowed to park there, what kind of vehicle. Maybe you've got a motorcycle-only parking spot. Maybe you've got a handicap parking spot. Maybe you've got one that says compact, or maybe one for RVs or something along those lines. The type of vehicle that's allowed to go in there is like saying integer or string or print stream. That's like labeling what can get stored in that location. The vehicle that actually gets parked there is the value. So you might say it is of type motorcycle, and then there's an actual motorcycle that gets put there. You might say a variable is of type integer, and then we put a 20 in there. Okay, and then from that point on, we can talk about that parking spot maybe by its number. This is parking spot 23, and that would be like the variable name. So it's a metaphor that works okay. It doesn't go all the way. You know, there's a point at which it breaks down, but it maybe helps us to understand what we're talking about when we talk about types. And for the same, and kind of in the same way, we want to type particular spots for various design reasons. You don't want to allow RVs to park in motorcycle spots, you know, for various reasons that we could make up. Maybe we don't have enough space for an RV. Maybe we have plenty of RV parking somewhere else and we need spots for motorcycles. And so by design, we choose a way to create our parking lot so that we meet several different needs, and the same thing happens in an object. We create many different variables to meet the needs of that object with types and variable names. All right, here's some examples of different variables and using them in different ways. So what I'd like to do is take a break, and we're actually going to take a 5-minute break now. We're about halfway through the lecture today. And in those 5 minutes, actually, why don't we take it till 11:20, so 8 minutes. That'll give us time to stand up, stretch, grab some water, do anything else we need to take care of. And also, I'd like you guys to run through these examples, try typing them in and seeing which one of them compiles okay and which ones don't. And then we'll return and go over what's happening with each of them. Sound okay? Anything going on Slack channel that we should address before our break? Okay. So try these out, and we will be back in 8 minutes. All right, audio back on. I'm up. Third goes away. All right, so we did a bunch of examples. Let's see, Lisa, you want to walk through me? What did you encounter with the first one? No problems. Good. Anything with the second one? Okay, so in the first one, we reserved an integer named width, and we stored 20 in it. In the second one, we reserved a space for a new variable called perimeter, and we stored the result of the expression 4 times width in it. So it should be 80. All right, next one. No problem. Just a side note on this. In my slides, often because of the way the slide software works, it'll put fancy quotes on my slides. You can see there's like these opening quotes and close quotes. When we're programming, there's only one kind of quote. It's a double quote. So don't try and put any fancy emoji quotes or anything in there. And likewise, if you see my slides messed up because it's got the wrong kind of quotes, know that you need to translate them into the straightforward double quotes. But okay, so string greeting equals hi wasn't a problem. How about the next one? Okay, so height equals 30. Can you tell from what we've covered so far what might be happening? Right. So what's happening there is you're not saying, like you said, you're not saying what type it is. It would be okay to put this line of code if somewhere above it you had declared height to be of type integer in this case. So it's not that you have to always say integer height, but the first time you use it, you have to say integer height. And you don't have to initialize it either. So that's right. The reason why it complained is because at this point we hadn't told Java what type height was, and so we can't really use it. All right, what about the next one? The type mismatch cannot convert from string to integer. How do you interpret what's happening there? Right. So on the right, even though the string contains numbers in it, that is considered a string because they're treating them as characters. So in this case, we're treating the 2 and the 0 the same way that we treat an A or a B or a Chinese character, traditionally or simplified. And so those quotes mean that what's being created there is as a string class, and we're trying to say, well, width should be equal to that string class. String class and integer classes are different, like a power plant, hot water tank are different, like a parking spot is different. So we can't make those work. So we're getting an error that says type mismatch. The type of the thing on the right and on the left are broken. Good? How about the next one? Okay, so by itself, duplicate local variable width, that was the error he said. By itself, integer width is okay code, but the reason why it's complaining in this particular case is because up above you've already declared an integer called width that is of type integer. So this fact that you put integer there first before the word suggests that this is the first time you're creating the variable called width. You're reserving space for it, but you've already done that. You've done that above. So if you were to comment out that first line of code, integer width equals 20, by putting 2 slashes in front of it, it should compile okay, because then the compiler won't have seen the initial place where we're reserving the width variable. I guess you also have to do the one integer width equals 20 where it's broken. Yeah, final one. Yeah, so same thing. We've already declared width. If you comment out all the previous declarations of width, this is valid code as well, as long as it's the first time you've seen width and height. So it's a shortcut. You can declare 2 variables at the same time in this way. Everyone okay with their version of their code? Makes sense? Okay. Great. All right, so the next thing to talk about with types is let's talk a little bit more about what other types are available to us. There are 2 number types that we're going to frequently encounter. One is the integer with the capital I. These are used for numbers that don't have a fractional part, so integer in the same way that we use integers in math. So anything, negative numbers are okay, 0 is okay, positive numbers are okay, but no decimal points. It has to be a whole number. The other thing is that because of the way we represent integers, there's a highest integer that we can represent, and there's a lowest integer that we can represent. And we were looking at them yesterday, actually, in a different class, and they're on it's something like 9 quintillion or something. It's really, really high. And so there is a limit. In most cases, you don't run into them, but you should be aware that there is a highest and lowest integer that you can represent. Another type that you might want to use is double with a capital D. These are used for floating point numbers. So if you want to represent pi, 3.1, well, that's a bad example. If you want to represent 1.5, you could represent that as 1.5. If you wanted to represent 1/10, you could represent that as 0.1. And a double type, you would use it the same way that you used integer, the word integer. It's just that the values that you can assign to it would be different. And then once you have variables of those kinds, you can combine them using the standard mathematical symbols, the plus, the minus, the asterisk for times, and the single divided by for division. I won't spend a lot of time on that because I think those are pretty straightforward. All right, so a third type we've seen is string. These contain sequences of characters. You can't use mathematical operations on strings, at least not in the same way, because they have a different behavior. And they behave differently in the context of those operations. All right, here is the rundown of the rules for naming variables. You don't run into this a whole lot, and what I really want to draw your attention to is the rule on the bottom. I feel like that's the one that students have the hardest time getting their head around. So even though it's on the bottom, let's start with that one. By Java convention, variable names start with a lowercase letter, for example, with the lowercase w, and classes start with an uppercase letter, like the capital I in integer. And we want to try and maintain that convention so that we can understand how we're using these different words within our code, so that we know when we're talking about a class and we know when we're talking about a variable. Once we understand capital letters and lowercase letters, the top tell us about how we can create a name. Like, we can't just use any word, we can use many of them. But for variables, methods, and classes, any of the variable names can start with any letter or an underscore character. And the rest of the characters can be letters, numbers, or underscores. So you just can't start a variable name with a number, otherwise the compiler thinks you're trying to write a number. You can't use symbols in your variable names like question mark or percent or space. Space kind of makes sense because it would be hard for Java to know whether you're talking about one variable or multiple variables. And then there's a very common style of writing variables called camel case, which is when you have, for example, this miles per gallon. When you want to have one variable, but you want to have multiple words to describe what's in that variable. And so you'll put all those words together, start it with a lowercase letter, and then the capital letters in between. Sometimes it's called camel case. I've also heard it called intercapping, which is usually what it's used when you see it in names of companies. So like you'll see a name of a company. What's an example of a company that has a capital letter in the middle of it? I want to say, like, I'm not sure Microsoft is like that, but you could imagine Microsoft would have a capital S in it. I don't know if they actually do that. I don't think they do anything. What about an example of a company that does that? And that'll come to me tonight at 2 in the morning. In any event, we can use multiple words together without violating the naming conventions by using camel case. And we call it camel case because those capital letters are like the humps of a camel. Names in Java are case sensitive. So if you say miles per gallon with a capital P and a capital G, that's a different variable than miles per gallon with a lowercase p and a lowercase g. And finally, there are some words that you can't use for variable names. You can imagine the reserved words that we already have. So there are some words like double with a lowercase d, class with a lowercase c. What else have we seen so far? Public, private, those kinds of words. There are some words that have special meaning in Java that will slowly grow in our understanding of those words, and you can't use those for variable names. You usually don't run into a problem with that because as you're typing them in Eclipse, if you happen to come across one of those names, Eclipse is going to color it differently, and so you'll be okay. Yep, boys. MySpace, good one. Yep, nice. Yeah, perfect. YouTube. Yeah. YouTube. There you go. All right, got to think internet. Perfect. Facebook have a capital B? I think it's B. sort of funny when you start thinking about it. You're like, what, is it a lowercase b or not? Facebook. Okay, comments. Just don't have to say a lot about this, but there are 3 kinds of comments in Java. You've got the double slash that will comment out a line. You've got a slash star star slash, that's a block comment. And then you've got slash star 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 slash, which is Java doc. So let's take a look at those real quick. What does it look like when you are doing comments? If you want to put if you just want to comment out a line, say you've got a line that you want to keep in there. Spell that right? Is that how you spell Dumbledore? Good? Okay, but it's wrong, so I'm going to comment it out. All right, so that double slash comments it out. It comments everything from the slashes to the end of the line. But if I wanted to comment several things out, I could do this, and then at the end of it, put the opposite pair of characters. That's going to comment out everything in between. The compiler is going to treat it just like text. And then there's a special kind of comment that enables you to write a machine-readable comment. That's JavaDoc. And if you start with a slash and 2 stars, then Eclipse is going to help you out, and it's going to add some bits in there that are going to be interpretable by a program called JavaDoc. And what JavaDoc does is it will read those special comments and create documentation for you automatically. We'll see that more going forward. Whoa. Documentation for people who would like to use your class. So if you want to look and see, well, we'll actually look online in a second. But if you want to use a string and you're like, well, how do I actually use a string? What is the behavior that's associated with the string? How do I use the different methods that are in a string? You have to look at the documentation. And many times the documentation is generated automatically from the source code, so that you have as little risk of the documentation and the source code starting to not reflect each other correctly as possible. By putting the documentation right there by the source code, it does a really good job of keeping them synchronized. Okay, so we saw the assignment command being used. The single equals is the assignment sign. It is the way that we assign a value on the right side to a variable on the left side. It's a single equal sign, and we want to make sure that we recognize that as being a thing. We've used it to initialize variables already, and we have to make sure that we have assigned a variable a value before we use it. Otherwise, we're going to get an error. Let me show you an example of that. And then we also have to make sure that the right-hand side can be an expression as well, just like we saw in println. So if we take our code that we've got here and we say, okay, well, what I'm talking about is I'm saying we have to make sure that we have assigned a value to a variable before we use it. Well, here's an example of reserving space for an integer called height, but we haven't initialized it yet. And if I have another integer called width, and I would like to give it the same value as height, and so I set it equal to height, I'm going to get an error because I've never given height a first value. And should say something like, the local variable height may not have been initialized. And in fact, it hasn't. So if I want to use that assignment statement, I just have to make sure that the right-hand side actually evaluates to some expression. So in this case, if I could put a number in here, I could actually put an expression in there. So this would be 10 times 5. And whatever the right side evaluates to will be placed into the variable width. It has to evaluate to an integer, of course. Or if I wanted to fix my problem, I could also go back and initialize height to have a value. And now when I do that assignment, I don't run into this problem. Straightforward. Eclipse really helps you out in this regard, so you don't tend to run into the problem too often. The other thing to be careful of is you want to make sure that you recognize that that equal sign is not the same as in math. So in math, when we have the equal sign, we say the left-hand side and the right-hand side are balanced. It's more like a scale. And so if we add something to the right-hand side in algebra, we have to add something to the left-hand side, and we use that property to do a bunch of work in terms of solving mathematical equations. It doesn't work that way. It's really a one-way expression. It moves things from the right to the left side. And I'll show you why that matters in a moment. We call methods. That's the process of making a method useful. We've seen that all objects of a particular class share those same methods, and we can call them on different objects. So println and print are part of the print stream class. We haven't seen very many methods on string yet, but strings all have a particular kind of method called length. So let's take a second and try and figure out what are the other methods that string classes offer. So what are some strategies that we could use for trying to figure out what the behavior of string is? Well, we haven't ever talked about that. We need that documentation, which is what we kind of just talked about. So let me first show you the shorthand way of doing it, and then let me show you the formal way of doing it. Okay? So what we're interested in is we're trying to understand what is the behavior of the string class, what methods do we have available to us that we can call. So the shorthand way to do it is just to create a string. Now we have that variable available to us, and the way that I would call a method is I would put a dot, and then I would call whatever method is on that string. So if I do the dot, Eclipse is going to give me access to all of the methods that I'm able to call. All of these are methods of the string class. So length, for example, that makes a lot of sense. If I highlight it, I get a quick snapshot over on the right of what that method does. So it says that it's going to return the length of this string. It's going to actually give me some of the details. It's going to say the length is equal to the number of Unicode code units in the string. So when you look at the documentation, you have to be very specific, because length can mean number of bits, it could be number of bytes, number of ones and zeros you need to represent it, but that's not what it's saying. It's saying it's the number of Unicode characters. So one Chinese character and one Latin character are both going to be 1, even though it takes more space to represent the two things underneath the hood of the character. So what else do you get? You get all kinds of things we don't really understand yet. Concatenate, substring, you can kind of make a guess about what those might do. Code point has a lot to do with the Unicode characters. We can compare them. We can ask if it ends with something. We can get bytes, don't know what that does. Index of, looks like we're looking in the string for something. We can ask if the string is empty. There's actually quite a bit of things that we can ask about the string object. All these methods are available to us, even though we might not know exactly what to do with them. What about other variables? What's the variable for our integers? We can do the same thing. We can say, well, we can convert it to a string if we want. We can convert the integer to a double if we want. We can convert it. We can do all kinds of other things. We can parse it. We can ask for the highest and lowest value of an integer if we want. That's a shorthand way of doing it. That's what you often use when you're doing the programming. But if you want to see the formal documentation, you typically will go to a website. You'll go to Oracle's website. And let me see if I can get this on the first try. So Oracle maintains the documentation for Java. When you look up the documentation, you have to make sure you're looking at the right version of it. And so we'll say Oracle documentation for string, and we'll look at Java 1.10. So right here, Java Platform 7, that's not what we want. We don't want 9. We're actually looking for 10. But what we'll do is we'll start here. And we can see that there's 7 in the URL, so I'm actually just going to hack that and see if we can get to 10 directly. There we go, great. So now you can see up here the search engine didn't work directly, but I got somewhere in the right documentation. This is at oracle.com, which is who maintains the official documentation for Java. We can see I'm working with the right version, 10. And now you can see all of this documentation for how to use a string class. It's in the weeds. It gives you some basic ideas about how to build the string, like you see here. Some other aspects of classes that we haven't talked about yet up here. And then if you come down here, you can see all of the different ways of creating one. And then you can see all of the methods. So summary of all of the methods. Here are all the methods that are in a string class. Let's look at the length one. That one seemed like it was pretty accessible. Alphabetical. So here's length. If I want to go into depth on it, I can click into that, and I'll get the detailed description of length. Now this documentation is in JavaDoc. So in the original code that comprises Java, these comments are all in a /** style, and then a program is going through and reading those and generating this HTML page for us. So just FYI, that's happening. But if you want to know formally how all these things work, this is what you would do. You would go to Oracle's website and find out more about string. See if we can do the same thing for integer. There's integer. You can probably use the search over here to do it the right thing, or do it the way they want you to do it. No. Let's Plus, it's trying to help me too much. Okay. So that's where we go for our formal documentation if we want to see what other methods strings offer. Let's actually use that. So let's we create that, and then let's do system.out.println. And what we're going to do is we're going to say, hey, please tell me. Actually, let's do it. Let's capture it first. Let's say integer x equals me.length. All right, so I'm calling a method on the variable me. The method name is length. It takes no parameters, so it's open and closed parentheses. It's going to return the number of characters that are in that string, which better be P-A-T-T-E-R-S-O-N, better be 9. And then I'm going to print out the value of x, if I can get my characters back to me. All right, everything's compiling good, compiling well, and we can see that it printed out 9. So the world is as we expect it to be. Okay, so what we did when we looked up that documentation is we were discovering what the public interface was of the string class. So public interface is a vocabulary word that we use in Java. It is all of the methods that you are allowed to call as a user of the string class. Okay. The public interface is all the methods that you're allowed to call if you are using a string. Length is an example of that. Substring is an example of that. There may be other methods that are there that are not part of the public interface, and if you're using the string class, you're not allowed to use them. That's the private interface. Java is different than Python in that it enforces that. If there are private methods and you're using a string class, you're not going to be able to use them. So it's one of the strengths of the Java programming model. Okay, so we can have two strings with the same interface. We've seen that already, actually. Just to drive it home, a particular method might have something called an argument or a parameter. That's things that we are passing in as data for the method to work with. So when we call println, we have to pass in what it is that we want it to print. So a string in that case. A particular method may have a side effect or a return value. So the top example there, integer x equals answer.length, when we call that method, the reason why we're calling that method is to capture the value of the integer that's coming back. So we want to know what the length of that string answer is, and we're storing it in x. So that's a return value. Length is returning a value. Println does not return a value that we care about. It has a side effect. The side effect is that it writes something out to the console. So it changes the world in some way, but it doesn't give us data that we can work with within our program. Can a method have both a side effect and a return value? No. There's one vote for yes. Anyone want to vote for no? Boaz says no. He hedges his bet and says he could be wrong. Sort of one of those statements that never needs to be said. That's like saying, I believe something is true. Well, of course you do. Otherwise, you wouldn't be saying it. So perhaps, yeah. Here's the classic, tangent for a second. Classic talking head statement on a news program. I'm not saying that Boaz is wrong. I'm just saying I wouldn't be surprised if he is. And you're like, wait, I just said something that sounds like I'm really brilliant, but I've actually committed to nothing, right? Yep. I'm not saying that the president is going to launch a nuclear bomb. I'm just saying I wouldn't be surprised if he did. And so you're like, it's like sounds like you've said something, but actually you've said absolutely nothing. That's just a trick. Yeah, nice. Yeah, so that if you're ever stuck getting trapped by a newspaper reporter, that's one strategy that you can use. The other one I'm not going to tell you on camera. I'll tell you guys privately. Side effects and return value. The answer is you can have both a side effect and a return value. So often methods will both do something that changes the state of the world, and you'll care about what they return. Okay, you can chain return values together. So I'm going to put this out here, and we've kind of seen it already, but I just want to make it clear. In this sequence of code, first of all, we have an example here of, oops, sorry, I went ahead too fast. The first example is an example of reserving space for a string and calling that variable river and setting that equal to MISSIPPI, or Mississippi. And now in the second case, you can see us capturing the return value of river.replace. And this is an example of why that equal sign is not like a mathematical equals, because you can see we've got river on both sides. But when we do river.replace isip with our, what we're doing is we're going to take the string that's in river, we're going to replace that ISSIPP with our, and what it gets returned by that function, we're going to store it in river and overwrite what was in river before. So whereas river previously was Mississippi, at the end of the second statement, river will now equal Missouri. So there's a movement of data from the right side to the left side, and you can see that there's a sequence to it as well, because river on the right side gets evaluated first before it gets reassigned the value on the left. That's important because you end up changing the value of river as you go through this code. All right, now in the third example down at the bottom, imagine the second one isn't there. Ignore the second one for a second. If we went immediately from the first line to the third line, the result of calling river.replace ISSIPP and our gets immediately passed into println. So we don't store it in a variable anywhere. We just take that result and pass it as an argument immediately into println. Does that make sense? Sometimes people get a little confused about what's happening there. It's inside the parentheses, so we're going to do the expression that's deepest in the parentheses first, and then we're going to pass the result as those interior functions get evaluated. Yes, it is valid to do just the first line and the third line without the intermediate. In fact, if you had the second one in place, oh no, the second one would be okay. If you did all three, it would work as well. It's just that if you did all three, that final call that's embedded within println of river.replace would actually do nothing, because the ISSIPP would already have been replaced. So there would be nothing replaced. And you get the same result, but you'd have this extra code that you didn't need to run. Okay. So let's try some of these. Let's take a pause and have you guys go through here. Now, before you run this code, what you have to do is you have to declare the greeting variable as a string, and you have to set it equal to something. So I'll let you do that, and then follow the code and see if you can understand why is it that certain evaluations are what they're doing, and then we'll walk through them in a moment. All right, so let's take 4 minutes to do that. Okay, we're back. We were walking through this code. One of the first things that we ran into when we were offline is the fact that we didn't have greeting declared. So before we had any of this code working, we had to put something above it that declared the greeting variable. So something that would work is to have a capital S string, space the word greeting, space the assignment operator equals, space some double quotes that have some text in it, and then a semicolon to end that. Right, so as we walk through that, what did you guys see was the effect of, maybe Tim, you want to walk me through what you saw the effect was of the different lines? What happened on the first one? Okay, so your greeting was high, and it printed high to the console. Okay, next line. Wait, you said that your string was HI? HI with the exclamation mark. Okay, so if you saw 3 printed out twice, you were seeing it. You're probably seeing it printed out from the bottom 2 lines. Yeah, that's right. Yeah, yeah. So it is the exact same thing. It's just in one case we introduced a variable in between. So when we introduced n, when we said int n equals greeting length, we introduced this variable, and then we use that variable in the following line, system.out.println n. That n is sort of not necessary. It's helpful for clarity, but in the final line, you can see we skipped that step, and we just immediately pass the result of greeting length into system.println. But what about that third line? What happened when we did greeting.length? Does greeting.length have any kind of a side effect? No. Does it have a return value? Yes. What did we do with that return value? Did we? How did we print it? And then just in the third line alone. Actually, we didn't do anything with it. So greeting.length evaluated to 3. So 3, that got evaluated to 3. Java did that work, and then the 3 just went away because we didn't store it in a variable until the following line. And in the following line, we did the same work again, but that time we captured the return variable. That makes sense. So in that third line, greeting.length, we did work, and it didn't do us any good. So the third line was superfluous. Did anyone have something that had an E in it? You had hello world. And what happened with the second line? Did it change your E's to 3? Or did it stay the same? Oh, that's right. We never printed it out. So why don't you, can you add a system.out.println greeting right after that replace line? Yeah, that's a good point, right? We never actually printed out what the value of greeting was afterwards. Okay, so greeting.replace doesn't have a side effect. It only has a return value. So instead of printing greeting, cut and paste greeting.replace and put that directly into println. Here, I'll show you what I mean there. I'm going to try and remember it. If we look at this code, okay, so this is the code as we had it, at least the relevant bits of the code. When we do this, it prints out our original text, and that's sort of a problem because we said, hey, I want to replace the E's with the 3's. But what the replace does is it only has a return value. It doesn't have a side effect. And so if we want to actually change it, we need to capture the return value by setting the result, what comes back, and by capturing the result and storing it in greeting. So we take what came back and we replace what was in greeting with what is there now. And now if we run it, we see that the E in hello world has been replaced by a 3. So that's just part of the documentation of working with some of these functions. You have to know whether or not it has a side effect or whether it has a return value. And it could have been either, right? There's no reason where by design we could have said that what replace does is it has a side effect and it's going to change what's present in greeting. If that had been the design, that would have been okay. And there's no way to know. That's an example of something that is not obvious. There's no way to know. You're not like somehow ignorant because you thought one or the other. You just have to learn what the design is and then work within that design. Okay, let's see. So we tried some. Okay, so let's summarize some of the things that we covered today. We talked about objects. So what we're talking about is we're working through chapter 2. And what this chapter is about is it's about using objects, manipulating those objects. Later on, we're going to talk about constructing them. So we know that objects encapsulate data and methods. So for example, a string has both the characters that we're keeping track of, but it also has things like replace and length that are methods that tell us about the data that we're encapsulating. And if we store a string in a variable, like we have a string called greeting, that greeting variable contains both the data and the methods. And we can pass that around, we can move that around in our code and use it in different places, and it encapsulates all of those characters together in one object at one time. So that's why we like objects. They abstract the idea of a string. We can start thinking about a string as its own unit rather than thinking about it as individual characters that we're keeping track of. Based on our class design, those objects then capture some design for a behavior. We think about how we want a string to work, and the objects capture that design by providing different methods that we can work with. Print stream is different than a string. A hot water heater is different than a parking spot. Variables, whatever kind we decide to use, store data. We typically store data within our methods or as instance variables. We saw integer, double, string. Those are the ones that we've used so far. We know that naming variables now has some rules. We like to use the convention of a lowercase first letter for variables and a capital letter for the definitions of our classes. And then there's some rules about inner capping, camel case, no symbols. We know that variables all have types. We can't just have a variable without a type. Other languages allow that. Python, for example, doesn't require you to name a type beforehand. And we know that Swift, if you've used Swift at all, does require a type, but provides a lot of support for guessing what the type is. Variables also have values, and in Java you can declare a variable without giving it an initialized value. So you can say there is a variable called width, which is of type integer, but I'm not going to say what its value is. Or you can then immediately assign it a value. We do that with the assignment statement, which is the equals. And then just as part of the practice of writing code, we know that we can put comments in our code in order to really quickly make the compiler ignore different parts of our code at different points. And we have 3 kinds of comments that we use. Most often we tend to use the java.comments comments and the single line comments. That's not really true. You use all 3 regularly. And lastly, we know that object methods can either have side effects or they can return values. And we find both of those behaviors helpful at different points. And a given object can do either one of them along the lines. Okay, so great. That's our lecture for today. Do we have anything coming in from online at all? All right, we'll have a few minutes to look at specifics here in person. Anyone have any comments that would be of general interest, perhaps, for everyone? All right. Then from Westmont Mayterm 2018 to the rest of the world, thank you very much. Signing off.